Okay, this is a Unit 12 seminar, and today I'm going to focus on rational inequalities because that's the most difficult part of the unit. Linear inequalities, so equations of straight lines, and quadratic inequalities we did in the MCR course. But rational inequalities means we're dealing with rational functions, so we have a numerator and a denominator. And inequality means we're either using the less than, greater than, less than or equal to, greater than or equal to signs. Before we get into some actual questions, I want to examine the graphs and talk about the notation that you're going to be using. So here we have one particular graph, and it says determine the interval where f of x is less than g of x. Okay, so this is our g of x graph, and that is our f of x graph. Now, if I am talking about, I notice that there is an asymptote, there appears to be an asymptote at the x is equal to 5 mark. That is our asymptote. Yep, so when x is less than 5, there is only an f of x graph. And when x is greater than, how about, let's say, 5.7, there is no f of x graph at all. So g of x is greater than f of x when x is greater than a little bit more than 5. So you could say 5.3, 5.4, 5.5. So to answer this question, when x is less than 5 and when x is greater than, let's say, 5.7, that could be your answer in the textbook. But on the test, or sometimes your answer has been translated to negative infinity, positive infinity, and it might look something like this. So x is less than 5. This is going to go all the way to negative infinity. So if I'm writing this in notational form, it could be represented as negative infinity, comma 5, and the union of 5.7 all the way to positive infinity, right? So we can translate this answer, and what I wrote in red means the same thing. However, up to this point, we've never dealt with writing the negative infinity and positive infinity per se. So that has been confusing some people on in the unit guide. So just so you are aware of that. Okay, I'm going to show you another. So just make sure you understand the first couple of slides. You don't have to make notes on it, because there's going to be a lot of note-taking when we actually deal with just the equations, okay? The graphs of the ones with equations, then you'll do in detail. So determine the interval where g of x is less than f of x, when g of x is less than f of x. So f of x has been I've highlighted the answer to this question, which is in between the interval. It might be hard for you to see. In the interval from -4 to -1. In blue, my blue graph, my f of x, is actually going to be when g of x is less than f of x, means in the range from -4 to -1, and then again from the range between 0 and positive 2, because after that the function would be greater than. So 0 is less than x is less than 2. That would be the answer to this question, when g of x is less than f of x. So I've highlighted that in blue. When you're talking about in between on the test, you should always maybe try to keep it in this interval. Either way, whatever you choose, we're going to mark it as right. I just want to make sure you understand the other notation is usually what the textbook uses, but you can use this notation on the test. If it was asking when f of x is less than g of x, my f of x I've highlighted in red, that whenever x is less than -4, so whenever x is less than -4, this happens. Then again, between -1 and 0, so when x is in between -1 and 0, and then again when x is greater than +2. So especially with more complicated graphs, you have to go through the entire thing and don't just choose one interval. Make sure that your answer is detailed, okay? That would be the easiest part of the test, just looking at the graph and figuring out which intervals belong to which. Now, what happens in your unit guide if it says solve algebraically and graphically? This is where everything you learned in the course has to come together, because it's not just solving for what the graph looks like. You have to be able to identify asymptotes, horizontal and vertical asymptotes. You might have to identify any discontinuities in the graph, okay? So this is kind of like the culminating test. Really, 13, 14, 15, 16 are all going to be on very separate issues. So up to this point, your 8, 9, 10, 11, 12, it's all leading up to this, this test. So we are going to have to make it very detailed, your answers. We'll start off very simple, and then we'll get to the more complicated questions. Now, to solve for x, for example, in this particular question, remember, even though it's equal to 0, we kind of look at this as a 0 over 1. Because when we cross multiply, x plus 2 times 1 is x plus 2. And then we have 0 times x minus 3. This gives me the fact that x plus 2 is equal to, the whole right-hand side is equal to 0. So x is going to be equal to -2. X is going to be equal to 2. That's solving algebraically. If I draw my graph, you're going to notice that your vertical asymptote is going to take place when x is equal to -2. Sorry, when x is equal to +3. That's going to be my vertical asymptote. And how do I get my horizontal asymptote for this particular question? Does anyone know? Because the x coordinates both have +1, right? What is the rule for horizontal asymptotes? It's going to be y is equal to 1. You're right. Still recovering from New York. Okay, hold on, but my graph, I drew my graph wrong as well, because the coordinate that you're solving for, x is equal to -2, has to be a part of your graph. So you're going to draw something that looks like this. We're going to identify that there is a vertical asymptote and a horizontal asymptote. What is the name of our vertical asymptote going to be? X is equal to +3, so you're expected to do that on your graph. And there is going to be a continuation. It's a rational function, so when you plot this on your calculator, you will get something that looks like that. Okay, that makes more sense. So very simple, straightforward, but it's going to get more complicated. Or should we go back to this? Okay, now we're going to start adding the inequalities into the mix. So the less than, the greater than sign. Okay, so solve algebraically. X minus 2 is less than 8 over x. Now, whenever we introduce inequalities into the mix, you have to have a table, and your table is going to incorporate the interval, the test number, the sign of the factors, and the sign of f of x, okay? This is going to be part of every answer on your test. That's going to be our last step, so let's go back to the original question. x minus 2 is less than 8 over x. So first of all, I am going to solve by bringing everything over to one side. Okay, so x minus 2 minus 8 over x is less than 0. First step. Now we have a denominator over here, so to bring everything under a common denominator of x means that we have to multiply the numerator by x. So we get x squared minus 2x minus 8 all over x is less than 0. Okay. Now, to properly examine or be able to generate a graph, what should my next step be? In order to properly examine intervals for this graph, what should my next step be? What could I do when I see a quadratic equation? What do you usually do? Yes. You want to find the roots or factor it. Yes, factor the top, because we have to remember that the x in the denominator is still part of it. So you want to factor the quadratic equation. It's not always going to be in the numerator. Sometimes it'll be in the denominator as well. So I know that x minus 4 and x plus 2 is the proper way of factoring my numerator over x is less than 0. Now, it's always a good idea to plug this in your calculator to figure out what the graph looks like, but from that final factored form of the equation, I know that I have 3 key points. So when x is equal to negative 2, when x plus 2 is equal to 0, so I have x is equal to negative 2. I have just x is equal to 0 by itself from the denominator, and then I have when x minus 4 is equal to 0, x is equal to positive 4. So the intervals that I'm talking about is when x is less than negative 2. Yes, that's the first case. And then I have in between negative 2 and 0. Then I have to examine the graph between 0 and 4. And then I have to examine the graph, finally, when x is greater than 4. That's how you're going to divide your graph into those 4 parts. When I say test number, so you're going to pick any number in this interval. So when x is equal to negative 2, I'm going to pick the number negative 3. In between negative 2 and 0, I'm going to pick negative 1. In between 0 and 4, I'm going to pick positive 1. And greater than 4, I'm going to pick positive 5. So any number in that interval. Now, when I talk about the sign of the factors, you have to look at my final step in blue. So if I'm picking my test number negative 3, I have to input that negative 3 wherever I see x and generate the appropriate sign. So I know that negative 3 minus 4 is going to give me a negative number. Negative 3 plus 2 is going to give me a negative number. And negative 3 by itself in the denominator would give me a negative number. Now that means that the sign of f of x, a negative times a negative in my numerator gives me a positive, divided by a negative is going to give me what? Positive divided by a negative is a negative. That means the original f of x function that we're trying to sketch is going to be decreasing in that interval from negative infinity to negative 2. The f of x function is going to be decreasing. We're going to do this with every single interval. Here our test number, negative 1 minus 4 is a negative number. Negative 1 plus 2 is a positive number. but all divided by a negative number. Negative divided by a negative gives me a positive. Positive 1 minus 4 is a negative number. Positive 1 plus 2 is a positive number. Positive 1 is positive. A negative divided by a positive is a negative. And x is greater than 4. So positive number minus 5 minus 4 is going to give me a positive. 5 plus 2 is a positive. All divided by a positive means that my interval is positive here. Oops, the f of x graph is going to be positive here. So this tells me exactly, or is going to lead me or help me sketch the entire graph. And then when you plot it on your calculator, you know that this makes sense. So does everyone understand how to do this? So we visited it before in other units, but this step, the sign of the factor step, we've never had to do before. You can't just plug it into the x plus 2. You have to factor in the entire equation. Okay. This is a question that involves, because we have a binomial in the bottom and a binomial in both the denominators, I'm going to help you solve this particular question, but we're not going to do the graph because I want to do a detailed analysis of the absolute value graph as well as another question, okay? So we'll have two questions where we explore the graph in detail. For this question involving time, this is actually a word problem. We're just going to practice common denominators, because I know that a huge problem that students have in the MCR course is what to do when you are bringing two binomials together as a common denominator. So stop me if you're confused at any point. First real step is to move everything over to one side. So we have 240 over t plus 8 minus 20t over t plus 1 is going to be greater than 0, sorry. So to get my common denominator, I'm going to put both my binomials together. So I have t plus 8 times t plus 1. And I know all of this is going to be greater than 0. However, you have to always remember that for this particular, for the 240, it's missing a t plus 1 to generate the common denominator. So we have to factor that in. 240 times t plus 1. And the key to this question is that it's a subtraction question. And that's where people run into the most difficulty. When it's addition, it's not difficult. But when it's subtraction, right now, the negative 20t has to be multiplied by t plus 8. So make sure you're doing this very carefully. I'm going to highlight in red. This is negative 20t, not just minus 20t. Negative 20t times t plus 8. So what students always do wrong is they forget to distribute this negative to the first term as well as the second term. I see this all the time on MHF tests and MCR tests. Make sure that negative is distributed to both, because when you do that, you get 240t plus 240 minus 20t squared minus 160t is greater than 0. And do not forget that you still have your common denominator of t plus 8 and t plus 1. So when we I didn't want to go that far. When we simplify this completely, you're going to have negative 20t squared plus 80t plus 240 all over t plus 8 t plus 1 is greater than 0. what does your numerator have in common? What is the greatest common factor? Anyone tell me? What can I divide every single term by? But do not take the negative, don't make that negative 20 disappear. You have to leave the negative 20 on the outside, and when you do, you have t squared minus 4t minus 12 all over t plus 8, t plus 1 is greater than 0. So negative 20, if we factor the numerator, we have t minus 6, t plus 2, all over t plus 8, t plus 1 is greater than 0. So in addition to showing you guys how to work with the common denominator, even though we're not going to fill out the whole table, I want to show you how you would fill out the table. So we have t is equal to negative 8, t is equal to positive 6, t is equal to negative 2, and t is equal to positive 1. On a number line, and sometimes it helps to draw a number line, we have the negative 8 first, then we have the negative 2, then the negative 1, then the positive 6. So you have to remember that this is going to be one interval, this is going to be your second interval, this will be your third interval, this will be your fourth interval, and then you have a final fifth interval. 5 different intervals. So you would have to do one when x is less than negative 8, when x is in between, so negative 8 and negative 2, when x again is in between negative 2 and negative 1, when x is in between negative 1 and positive 6, and finally when x is greater than positive 6. For some reason, kids on the test have no problem with the in-betweens, but they forget the final 2 intervals at the end. So make sure that you don't make that mistake on your test. Okay, finally, 2 more questions. I want to do one in absolute detail and work with an absolute value function. So I'll give you a few more seconds to copy that. Okay, so we have this absolute value function, which I'm going to show you how to solve, but let's do one more function, a quadratic over a quadratic, in detail. We're going to go through the major steps so you know exactly what you need to do on your test to get a very good mark, okay? So first, you can do it on your own. Step 1, factor the numerator and the denominator. Okay, so if you did it properly, you should have written down x minus 2 times x plus 1 all over x plus 4 times x minus 3 is greater than or equal to 0. That's what you should have written down. Okay, step number 2, which is very important in order to draw the graph properly. Find the asymptotes and the intercepts. So we're going to start with the easiest part, my vertical asymptote. So I have x plus 4 is equal to 0, so that means that x is equal to negative 4 is one of my vertical asymptotes. And then I have x minus 3 is equal to 0. So x is going to be equal to positive 3. 2 vertical asymptotes. I mixed up my horizontal asymptote last time, but you guys were right. So because I have y is equal to a quadratic function over a quadratic function, they cancel out, and y is equal to positive 1. That is my horizontal asymptote. Now my x-intercept. If we take our function, 0 is equal to x minus 2, x plus 1 over x plus 4 and x minus 3, and we actually cross multiply, you'll notice your whole denominator goes away, so you're left with x minus 2 times x plus 1 is equal to 0. So that means my only x-intercepts are going to be when x is equal to positive 2, y is going to be equal to 0, and when x is equal to negative 1, y is equal to 0. Why are the other two values not x-intercepts? Can someone tell me? Why is positive 4, negative 3, x plus 4, x minus 3, why don't they automatically represent x-intercepts as well? What are the significance of those numbers? Yep. Exactly. They're asymptotes. The graphs are not allowed to touch those values. Therefore, it's impossible for them to be x-intercepts. However, I frequently see on tests students stating that they're x-intercepts, even though they just stated up there that they are also asymptotes. Finally, the y-intercept. Remember, in order to find my y-intercept, I have to let x equal 0. So if y is equal to x minus 2, that gives me 0 minus 2, which is negative 2. 0 plus 1 is positive 1. 0 plus 4 is positive 4. 0 minus 3 is a negative 3. So that leaves me with y is equal to negative 2 over negative 12, which is the same as positive 1 over 6. So my y-intercept would be when x is equal to 0, y is equal to 1 over 6. So those 4 pieces of information are essential to get all your marks for a question. Now, something that the textbook asks you, and I've seen on some of the practice tests, correct me if I'm wrong, is the whole concept of the number line. So instead of, in addition to the interval chart, you need to know how to represent the intervals on a number line. So I'm going to show you that we stated there is a vertical asymptote at negative 4. So first of all, at negative 4, what you are going to write is vertical asymptote. Or let's write it at the bottom. Vertical asymptote. Then we have at negative 1 is our next value. Then we have a value at positive 2, at positive 3, and I believe that is it. So my intervals are going to be when x is less than or equal to negative 4, in between 4 and negative 1, in between negative 1 and positive 2, in between 2 and 3, and finally x is greater than 3. You want to be able to identify that at positive 3 we have another vertical asymptote. You want to identify your x-intercept, so you would say at positive 2 you have an x-intercept. At negative 1, another x-intercept. And finally at 0 and 1/6, I believe. So, or no, we wouldn't put that because this is, number line is always with your x value. So that would be enough for representing your intervals on a number line. And finally, I want to sketch my graph. I want to know what my graph looks like. Bless you. So I would have to fill out my whole table. So x is less than or equal to -4, in between -4 and -1, in between -1 and +2, in between. I'm going to do this very quickly, so only stop me if you don't understand something that I'm doing, but this is a good question to write in detail. My test numbers that I chose were -5, -2, 0, 2.5, and +4. Now my numerators multiplied together when this is my test number is going to give me a positive, and my denominators multiplied together is going to give me a positive. In this case over here, a positive and a negative. Negative divided by a negative, a positive divided by a negative, and a positive divided by a positive. So I am expecting my graph to be increasing. When x is less than -4, the graph is going to be increasing. In between -4 and -1, decreasing, then increasing again, then decreasing, and then increasing again. And I'm actually going to sketch out my graph. Can I change to the next slide? So what this is going to look like when you plot it on your graphing calculator, make sure that your asymptotes are all there. So I have y is equal to 1 as my asymptote. I have another asymptote at x is equal to -4 and x is equal to +3. And the graph is going to look something like this. In this interval, it's going to go like that. And I said my x-intercepts were at +2 and -1. And remember, my y-intercept is up here, so your graph has to tell the story of everything that you discovered in the previous 4 steps. If your graph doesn't match the other steps, there's a problem. It's also very simple to get your axis of symmetry, because it would just be adding your x-intercepts and dividing by 2. So x would be equal to -1/2. That would be your axis of symmetry. So really, to make this graph the most accurate as possible, but anyway, it's going to go something like that. Does everyone understand that? It's not difficult. It just requires a number of steps, and always double check your answers. So that's about it. I do want to quickly, I'm not going to go through the whole process, but I do want to show you an example of how to solve an absolute value function. So we're not going to actually draw it out, even though I might just sketch it on the side. But remember, when you have an absolute value function, you have to do 2 scenarios, the positive case as well as the negative case. If I have my positive scenario, I would just have the question as x over x minus 4 is greater than or equal to 1. But I also have to consider the negative case meaning negative x over x minus 4 is greater than or equal to 1. That means you would have to punch two functions into your calculator. You would have to solve for x over x minus 4 minus 1 is greater than or equal to 0. This means that x minus 4 times x minus 1, because this is 1 over 1, this would mean that x minus 1 times x minus 4 all over x minus 4 would be greater than or equal to 0. And to simplify that further, this time there's not two binomials, it's just the negative 1 that's being distributed. So my final answer for this would be 4 over x minus 4 is greater than or equal to 0. If I solve the negative case, I would have negative x over x minus 4 minus 1 is greater than or equal to 0. That means that negative x minus 1 times x minus 4 over x minus 4 is greater than or equal to 0. Again, this is not FOIL, it's just the distributive property that negative 1 gets distributed. So when you simplify, you're going to have a negative 2x plus 4 over x minus 4 is greater than or equal to 0. You're solving two separate equations in one question. And when it's time to sketch the graph, you're going to find that we have our x-intercept is going to be 0, 0. My y-intercept is also going to be 0, 0. We have a vertical asymptote when x is equal to positive 4, and a horizontal asymptote when y is equal to positive 1. So y is equal to positive 1. Here x is equal to 4. I know my x-intercept and my y-intercept are the same. If we filled out the entire table, you're going to find that the graph looks like this. It has a cusp that then it travels upward like this. So the asymptote only applies to this part because your intervals, and that's all affected by your intervals. The asymptote is only applies to this function and this part of the graph. This cusp is going to pass the asymptote. And that's where it gets complicated because you're merging both of the graphs together. You're basically plotting both separate functions on one graph. Okay? So if absolute value functions are probably the trickiest, I'm going to give you a bonus question in case you want to do it. So the graph will be separated into 3 parts. Again, you will have a part of the graph that crosses the horizontal asymptote. Okay, we're done.